All right, so me and Danny are going to be taking you through the forces example problem where the woman is pulling her child to the left at an angle of 40 degrees. So first what we want to do is we want to draw our rough sketch of the FBD. Okay. So you got to do our little dotted lines here, and we got to draw our force of tension coming out at an angle of 40 degrees. We have to get our normal force line and our force of gravity line. And then with the force of tension, there's a component in the parallel direction and a component in the perpendicular direction. So we have to draw those lines too. So here's our force of tension in the parallel and force of tension in the perpendicular.
And since this is a constant velocity problem, we have to make sure that our FBD is balanced. So we need the force of friction.
All right, and make sure you have your theta in there because we are pulling at an angle. So now since we have our rough sketch done, we have to go to our final sketch. So we're going to do the same thing here. And in the final sketch, we don't have that sort of angular component. It's broken strictly into perpendicular and parallel. So on the top here, we have both the normal force and the force of tension in the perpendicular direction, and then our force of gravity pulling down. So those two are going to be equal because we're not moving in either up or down. So we have to draw our equity marks. And then in the parallel direction, we have our force of tension in the parallel and our force of friction. And those are also going to be equal because we're moving in constant velocity. All right.
Now, to make this quantitative, we have to look at our problem and see that the woman can apply 90 newtons of total force.
So let's draw what we know here. So our total force of tension is going to be 90 newtons.
Mm-hmm.
So in order to find the force of tension in the perpendicular direction,
we have to draw a triangle.
Yes, we do. Should we draw?
Yes, draw the triangle.
All right, we'll draw the triangle here. So our angle is 40 degrees. Oops. We have 90 newtons here. So we want the height portion of this
the
triangle.
perpendicular.
Yeah. So this is what we want. So we have to do sine of 40 degrees is equal to
opposite over hypotenuse. So you got your force
of tension
in the perpendicular over your 90 newtons.
Your total force of tension is equal to sine of 40 degrees is equal to force of tension perpendicular over 90, and then 90 sine of 40. So you can do your force of tension perpendicular, which makes your force of tension in the perpendicular
57.85 newtons.
57.85 newtons. So now that we have that, so that would be here. 57.85 newtons.
Now we can move on to our force of gravity.
Yes, we definitely do need our force of gravity here. So we know that force of gravity is equal to the mass times the acceleration due to gravity. So Fg is equal to, and we know that the child in this slide combo is 20 kilograms. So it would be 20 kilograms times 9.8 meters per second squared, which should give us
196 newtons.
Okay. So now we have both the force of gravity and the force of tension in the perpendicular direction. So now that's all we need to find our force normal now. Let's see if we have space. So since we have our equity marks here, we know that the force of gravity is equal to the normal force plus the force of tension in the perpendicular direction. So we want the normal force. So what we're going to do here is we're going to subtract the force of gravity minus the force of tension in the perpendicular direction. So Fg minus force of tension in perpendicular is equal to the normal force. So we know that our force of gravity is 196 newtons, and our force of tension in the perpendicular is 57.85 newtons. So that makes our normal force now
138.15 newtons.
138.15 newtons. And there you go. That is all. Hopefully that helped. Hopefully that was easy and understand, but it doesn't look like it on the board. So there you go.
We gotta solve for FT parallel.
Okay, so in order to make this fully quantitative, we're also going to want to find the force of tension in the parallel direction, which is really easy. So if we go back to our triangle here, the same way that we found the force of tension in the perpendicular direction, instead of doing opposite over the hypotenuse, now we're going to do adjacent over hypotenuse, which is cosine. So what we're going to do is we're going to take the cosine of 40 degrees is equal to the adjacent, which is FT parallel, over the hypotenuse, which is FT. Cosine of 40 degrees is equal to FT parallel over 90. 90 newtons times cosine of 40, because we have to multiply it over, is equal to FT parallel, making FT parallel
68.94 newtons.
68.94 newtons. So, if we write on our little FBD here, we have 68.94 newtons. And notice how we also have equity marks for force of tension in parallel and force of friction, so that our force of friction is also going to equal 68.94 newtons. But since it's opposing our direction, it's going to be negative. Which force of gravity is also negative. I forgot to mention that before. There you go. That's all.
That's all.
Hopefully that was simple.